Test 1 2 1 2. All right, perfect. Saturday. Welcome back to pain. All right. For today, we got to get through 3 more chapters, which are 6.4, 6.5, and 7.1. 6.4 is all about work. And to understand work, there's one equation we have to know first. Actually, that's an equation. Basically, work is equal to force times distance. Force could be something like newtons, which would be a unit that's kilogram times meter over second squared. Distance would simply be, well, meters. Actually, no, this should be, yeah, this is right. Oh, that's fine. Work is measured in joules. And joules, which is a J, that's what's joules measured in? Newton meters. Basically another name for Newton meters. Or it could be foot pounds. And let me check to make sure the volume everything's fine. Yeah, alright. Okay. Let's see. I don't really know how to explain this. Will be best demonstrated by a problem. First question is number 3, which says, ooh, oh no. A force of 5x to the negative second power pounds moves an object along a straight line. When x is when it's x feet from the origin. Find work done between actually, now it sounded like I'm pretty sure I put this very wrong way. Force is not measured in newtons. It doesn't have to be. Or is it? I'm confusing myself. I'm not as great with physics as I am with just math. So when there's units, I get confused. If I work done between x equals 1 and x equals 10. Right, so work done is gonna be our W. That is going to be equal to our force times our distance, but instead we're gonna have an integral. Since it's a variable force, we would have 5x minus 2 when x is a distance, and the distance that it's being pushed, which would be infinitely small as we go between 1 and 10, would be dx. This integral would give us the work done. And just to check the units are all in feet and pounds. All in feet and pounds, that's good. That means we're gonna end up with foot-pound, and we don't have to convert any unit. It gets really terrible when we have to convert units. You need to write some really big or really small numbers. It might work well with the calculator, it doesn't work well with my brain. And if we take the integral, that is what? -5 over... hang on. Just -5x to the power of -1 from 1 to 10. And if we plug in numbers, we get -5 times 1 over x minus, not 1 over x, 1 over 10 minus 1. Let me see. Yeah. That gives us -5 times 9 over 10, which would give us... this is negative. Which would give us 9 over 2. And the answer would be 9 over 2 foot-pounds. Okay, that's a pretty easy one, especially since it's 2D. It'll probably get bad once we add volume to the equation. Next up is going to be number 7. 7 says a force of 10 pounds required to hold a string stretched 4 inch. Holds a spring at, or rather stretched 4 inches, and it wants to know how much work is done in stretching the string 6 inches. Might look like an easy problem that you can just get a ratio, since the equation for force required to hold a spring is just F equals kx, where k is a spring's constant. But it's asking for the work to stretch. You start at 0 and you stretch it to 6 inches. So we're still gonna need to use the integral. And also, I need to be gone for a moment. Well, all right, and I'm back. Oh yeah, I actually forgot to do this. I'm gonna try to put some music in the background and see how that turns out. So volume should be decently low, so you shouldn't be interrupting the pain. Now, first step here would be to actually figure out the spring constant K. So we need 10 pounds. And yeah, I was really done with that. Force is not measured in newtons, it's just measured in whatever strange thing you might want. Or is it? Wait. No, I was thinking yeah, it is measured in newtons or foot. That's what I was thinking. I keep forgetting things. So yeah, measured in newtons or foot. I just realized that when I look at the equation for joules. Anyways, 10 pounds is equal to K times 4 inch. That means K is equal to 5/2 pounds over inches. And once we have K, we can integrate our equation. If we find the work, we would with the integral of K, which is 5/2 pounds, and then X. Mel. The cat is here. Okay. And we want to stretch the string by 6 inches, so we will start from 0 and go up to 6. This would be your integral. Oh, and before I forget, dx. If we integrate that, we get what? 5/2 x squared. No, 5/4 x squared. And I remember now, last class I was putting the line on the left side, but in the books they put it on the right side. I never actually realized that until now. So we're left with that. Let's plug in numbers. 6 squared, or rather, let's see. 36. 9, 5 times 9 is 45. Yeah, 45. But if we're having work, it should be in foot pound, but this is currently in foot inches. The distance measured in inch, so inches squared. Hello, Kilronet. If you're here on a Saturday, you're in for the torture. And this is in foot. What am I saying? Not foot inches, pound inches. Hey, at least we got music this time. But we don't want pound inches, we want pound foot. Or foot pound. You just had my math test. How do you do? So we multiply this by 12 inches over 1 foot. Think you did well. That's great then. Mass, one of the most abstract concepts, I would say. Probably the most useful thing you'll learn in school. Unless you're taking things like calculus. When are you ever going to use calculus in school? I mean, outside of school. But anyways, we can take out 3 from 45 and 12. We get 15 over 4. And that would be in foot pound. When I have a math test, it's basically always questions on some parts of the homework, so it's always pretty easy if you've ever done the homework. If you just memorize everything from the homework, you would be able to pass the test. Number 9 is a 2-part problem. Oh god. It looks like they're giving mixed units, which would be pretty bad. Number 9 says 2 joules of work is needed to stretch a string from its natural length of 30 cm to 42 cm. I know there are some math teachers that give questions on the exams that they basically never talked about in class or mentioned in any of the homework. Why did my friend had that scenario? And basically no one knows the questions. Oh yeah, this is called Hooke's Law, I just remembered. Get down here. Oops, not that color. So the actual length being stretched, the X in the Hooke's law is actually going to be 12 centimeters. And then there's two parts. A says how much work to stretch from 35 centimeters to 40 centimeters. Part B asks how far beyond its natural length will force of 30 and keep the string stretched, but we'll talk about that later. Okay. 2 joules from length of 30 to length of 40. Ooh, we haven't went over a question like this one in class. We were always given the force, but not the work. However, if you have the force... Oops. Zooming is so weird. 2 joules is just 2 Newton meters. Then if we divide that by our stretch length, which is going to be 0.12 meters, so if we convert centimeters to meters, that will give a... I hate decimals. 2 divided by 0.12 is going to be 50 over 3. Newtons. Fraction, gang. No decimals. And if we have that, we can start getting our constant K. If 50 over 3 Newtons. Actually, did that work? I think it works. And 53 newtons equals to K times 0.12 meters, 0.12 meters. Then K would be equal to not another decimal. 50 divided by 3 divided by 0.12 would give us not a great answer. I'm just gonna estimate this one. About 139. And I might put in the right unit. Newton over meters, yeah. And then what comes next? Now, how much work do you stretch from 35 to 40? So if the natural length is 30, so we're actually starting from 5 centimeters, which is going to translate to 0.05 meters, to 40, which is going to be 0.1 centimeter. And then we have our K and X. Ooh, if I integrate this, we will get 139 over 2 x squared from 0.05 to 0.1. Alright, I'm not calculating that by hand. Sorry. So 0.1 squared is 0.05 squared times 139 divided by 2. God, I think I just did something wrong. Huh. Yeah, something was a little wrong. I need to think for a moment. Huge also work, yes. Ah, what went wrong? Am I supposed to do this? If I do that, does that really change anything? I think it does. So if I have 0.12 squared divided by 2, then we do 2 times that. You know, where's this thing? If we solve for that, we will get k equals 9/625 Newton-meters. Assume I did all that calculation correctly, didn't suddenly mess up somewhere. In that case, everything did here is wrong. So if we have our k now, we could then... Or is it? Hang on a minute. Now it feels even more wrong. But the math says it's right. If we do the equation again, let me do it in my calculator real quick. Where's x? X. We will get some incredibly small number, which is probably not right. Wait a second. Yeah, I just realized what I did wrong. I made another algebra problem. Oops, don't mean to raise that much. Because I was supposed to divide by the sign of x, like, instead of... What did I do? My brain's not up to this at this moment. So if we solve for that again, we get 2 divided by our answer times 2. You get k should be 5,000/9 Newton/meter. And then we integrate, let's just take k outside, from 0.05 to 0.1 of x dx. That is simply going to be 5,000/9, which is okay, times 1/2 x squared from 0.05 to 0.1. Now I have to rely on the calculator again. Oh, hang on just a minute. Still doesn't feel right. Where did it go wrong? I probably typed something wrong again. Oh, I forgot to multiply in the 1/2. That's where all the math went wrong. So this would be 2050 over 9. And then this would be 250 over 9, which would make a lot more sense. And then if you do the math, that would turn out to be... Where is it? (25/24) joules. And that would be the answer for part A. 3 questions in, no, 2.5 questions in, and I'm already struggling this hard. Now we turn to B, which says, how far will 30 newtons stretch? Or rather, 30 newtons keep the string stretched. That seems like a easier problem to deal with if 30N is equal to or spring constant. So there's the spring constant is Newton over meters times or distance. So we just gotta solve for D, which would give us well, that doesn't really help. All right. D is equal to 27 over 2050. That is really this. That's really small. Should I put this in decimals? I'll just leave it at that. 27 over 2050 meters. That feels too easy. Did I read the question wrong? Looks right. Alright, so we got 11, which says string has a natural length of 20 centimeters. Not string, spring. Why do I keep writing string? Not string. Probably because I use strings a lot more than spring. Of 20 centimeters. Compare work 1, which is going to be work from stretching from 20 centimeters to 30 centimeters. And width or 2, what do I use? Width, compare W1 width, W2, or compare W1 width, or 2 W2. But W2 as a result, work spent from stretching between 30 centimeters to 40 centimeters. And is asked, how are W2 and W1 related? Well, since we don't need to care about units for this one, they're all in centimeters. I suppose they want W1 or W2, one in terms of the other. So if the natural length of the string is 20 centimeters, stretching from W1 to from 20 centimeters to 30 centimeters would be from 0 to 10, from its natural length to 10 above its natural length. And we don't have a constant, we don't have weight, we don't need to solve for the constant. We can just put k off to the side here and x dx, which is going to be equal to 1/2 k x squared from 0 to 10. So that would be 50 over 2k. And if we do the same to the other one, ooh, wrong color, wrong color. Quick. Oh no! What's the right color? This should be the right color. Alright, then we stretch from 20 to 30. Not 20 to 30, 10 to 20. I keep making small mistakes because 30 is 10 from the natural length, 40 is 20 from the natural length. We put k off to the side. X dx, same thing here, except it's from 10 to 20. We would end up with 400 minus 100, 300 over 2, 150 over 2k. So it's clear that W2 is 3 times the amount of W1. Which is actually pretty easy, considering how confusing this problem looked. Let's write equal sign here too. Onward to number 15. Burger King foot lettuce. Oh, I just have to say that every time we get to 15 something. A cable weighs 2 pounds per foot and lift 800 pounds of coal. Up 500 feet. Fine work done. Straightforward enough. This is a bit more complicated than the previous problem because we have a variable weight. Because what do you call it? Yeah, or force is going to be the coal plus the weight of the cable. But the cable, as you lift it up, parts of it become on the ground level and you have less cable to weight, if that makes any sense. So the force is actually going to be equal to 800. That's our coal that remains constant. And it's going to be plus 2 times how far we are up the, rather, is it? 500 minus x, where x is how far we lifted up so far. Let me just check my stats to make sure that's right. Actually, it doesn't actually even matter right now, for this question at least, but that's right. We go from 0 to 500. Or weight is gonna be 1,800 minus 2x, and our height, how far we put up the x, the specific moment in time. And if we take the integral of that, we get 1,800x minus x squared from 0 to 500. Calculator time. Units all in pounds and foot, so we're good on unit. Don't have to convert anything. We get 6.5 times 10 to the 5th power foot-pounds. There we go. Next. About halfway done through 6.4, I think. Next up is number 19. Number 19 says 10 feet chain, weighs 25 pounds, find work done to lift one end, rather, let's say hangs from a ceiling. I hate writing. Find work done in lifting one end of the chain up to the other. So let's say we have a chain hanging here. We want to lift it until it looks like this. So if this is 10 foot, we need to lift up 5 foot of chain at most. So, would equation work? 25 pounds times x length of chain divided by 2. What? Divided by wouldn't have to half the chain length. 1 over 10 foot x. So our equation for force would be 25 over 20x. Oops, wrong color again. Meow. Okay. This should give us the weight of the chain that we must pull at the moment x, where x is how far up we pull it. If we want to take the integral from 0 to 10, because we're moving up 10 foot, even though we only need to carry 5 foot of weight. And then 5 over 20x dx. So we're left with 25 over 20 times 1/2 x squared from 0 to 10. So 100 over 2, that's 50. Whereas 100 over 25, 5 times 25, 125 over 2. With pound. That's our units. Looks about right. So we must move on to number 21. 21 says, why is there so many word problems? Okay. An aquarium. You know what? I'm gonna draw the picture instead. Hmm. 2 meters long, 1 meter deep, 1 meter wide. It's full of water. Watching Mulan. Wait, the original one, or was it the Disney one? Disney made a Mulan movie, right? I watched the original before, but not ones made by Disney. Yeah, I haven't watched the new one. I watched the original, though, so I do know the plot. Anyways, it also says density of the water is 100 kilograms per meter cubed. Wait, both of them are Disney. Really? I did not know that. Oh. I thought Mulan was like a really old Chinese story. I guess it's all Disney. Everything is Disney. There's no way around it. And find ore to pump out half the water. So they made a movie about Hercules too? Ah, I missed so many movies. I need to find time to watch some of the movies. I was just catching up on some of the Marvel movies like a month ago. But I know pretty much nothing about what movies are out there now. And I still don't know whether that's pronounced Hercules or Hercules. I think it's Hercules. Hercules? I don't know. English names are bad enough. Greek names take it to another level. Hercules. Okay, good. My intuitions got something right. I'll see if I can check that movie out. Anyways, our volume is going to be, since we have a cube, its cross sections and cutting it horizontally are all the same. It's going to be 2 meters times 1 meters times x meters. where x is how far up we are. So it would be 2dx. A single cross section would be 2dx. It would be measured in meters cubed. If the density of water is 1,000, we put that 1,000 out here. Kind of tired of seeing all these different units hanging around. And since we only need half of the water, we're just gonna go from 0 to 0.5. And no matter which direction we take the half from, the resulting answer is gonna be the same. So I'm gonna take the easy way out here and have 1 is gonna be 0. And then 2x dx. And if we integrate that, it'll be 1,000 x from 0 to 0.5. Alright, calculator, do your job. Okay, maybe I didn't need a calculator. This is going to be 2,500. If we have kilograms and meters, we're gonna have Newton meter, which is gonna be joules. There we go. Oops. Ooh. Now for perhaps my least favorite of all questions, which is 23. What I do like about 23, however, is that it gives you a diagram. We have a triangle here. We have select problems that we must do. So for 6.4, I think that's 6.4, we gotta do 3, 7, 9, 11, 15, 19, 21, 23. If I had to do every problem from 21 to 23, that'd probably be a whole day by itself. Not counting even sleeping. We have like a straw here, which is 2 meters. And the height of the triangle is 3 meters. The width is 3 meters. And I feel like I've seen this kind of shape somewhere before. Like the things they used to feed cows, if you cut off the bottom half. And the depth is gonna be 8 meters. So for this one, I'm gonna have to draw a diagram, or rather... Toblerone! Okay, that's what I was thinking about it. I remember now. Toblerones, they make the best chocolates. Anyways, 23 wants to know how much work to pump out all the water. This is water. It's filled with water. Therefore, old people. Oh man, now that I think about it, I haven't had Toblerone in years. Anyways, it says water is 62.5 pounds per feet cubed. Oh. Oh no. We have pound feet here and we have meters over here. Actually, I don't need to do math. Water is about 1,000 kilograms per meter cubed. Yeah, I might get a slightly different answer from using 62.5 pounds per feet cubed, but it's gonna be very negligible. We'll just use 1,000 to stay clean. And our volume is going to be 8. Actually, let's draw the diagram first. This is the shape. This is 3. This is 1.5 because it's half of 3. We get an equation y equals 2x. Therefore, x is equal to 1/2 y. All right. Since this is gonna be 2 halves of the triangle, we can have volume is equal to 8 times 1/2 y dy. That's our cross section. What do you call it, cross section? Actually, you go. But we have 2 halves of the triangle. So we need to multiply that by 2. 3. Yeah. So that half and the 2 cancels out. We're left with 8y dy. And if we take the integrals 1,000 times, we want from 0 to 3. Oh, well, wait, another thing we gotta take into consideration, which is that the straw is 2 meters above our triangle. So 3 plus 2 is 5. We're gonna put up at most 5 meters, at least 2 meters. So 5 minus y, 8y dy. God, no, this isn't it. Well, y and 1/2 y. It will look more like 8, or rather 2 times 8, because we have 2 halves of the triangle, times 8, which is the depth, times the height, times the width, which is going to be 1/2 y. Except we have 5 minus y. All right. Actually, now that I just think about it, do I need gravity? We're given the weight density. Huh. We have 3 equations for density of liquid. The force equals mg, which is mass times gravity. Number answer. Have F equals mass times gravity, mass times the mass density times volume times gravity, or equals to something strange symbol V, which is weight density times volume, and we were given the weight density. So we do not need to take gravity into consideration. Therefore, let's say we have 1,000 times from 0 to 3, 5 minus y, not 5 minus y, 40y minus 8y squared dy. That would give us from 20y squared minus 8 over 3y cubed from 0 to 3. 3 times 3 9 72 3 squared 180 minus 72. Oh man, I'm not gonna do this by hand. That will be equal to 1.08 times 10 to the 5th power, which is apparently not right. Now, where did I make a misstep? This is somehow really close. Let's test out a few things. That's strange. But I didn't consider gravity. But for given the weight density, we do not need to calculate gravity. Where did things start going wrong? Gravity makes stuff go down, basically. But this number's already been pulled down by gravity. Oh man. Of course, the last problem of the section is gonna be hard. So this is not an arithmetic error. This is like the first calculus errors that I'm making. One that's not algebraic. Can I find an example of this somewhere? One that I can refer to? Am I messing up mass density and weight density? If I did, does that mean the answer question is wrong? Oh, I see. Ah, gravity. Gravity was the problem. I've been using the wrong formula. And somehow miraculously gotten the wrong mathematic answer. Got the wrong math answer, algebra answer, which led me to make a calculus problem. Well, the answer here is right. I forgot to take into consideration gravity. Gravity is like 9.8 meters per second squared. But I'm just gonna write 10 because 0.2 is not gonna mess up my answer. And I somehow got into 250. Which if you use 9.8, you'll get about 2,450. That was the problem all along. I forgot to add gravity into the equation because we're not given weight density. We're given mass density. Now, if I can just move all of you along the way to make space for an extra 10, that would be fantastic. So in the end, yes, another algebra problem. And if we add that 0, instead of 1.8 times 10 to the power of 5, we have to the power of 6. If we add that extra 0 in there. The book says 1.06 times 10 to the power of 6, but that's probably because I used 10 instead of 9.8 and 1,000 instead of 1,001. I think that a 2% margin of error is enough. But here's the thing, how I'm gonna search up Google for this problem where we have a diagram? I guess a reverse image search? It's not as fun if you use Google. Alright. That was all for 6.4, which was not as hard as I expected it. Because my god, did I hate converting units in physics. We do love maths. Yeah, I wouldn't be doing this out of my own free will. I'm not a big fan of self-harm. Ugh. Here's the thing, biology Biology is easy, but it's very boring. Until the part where we get to dissect a frog. Yeah, we get to dissect the frog. And Kiranat, I think, actually got to dissect a goat's heart. I don't know if it's for a satanic ritual or what, but it was studying biology class. We get to dissect stuff. Math, though, a lot more fun. Anyways, what is 6.5? Average value? Is that what it's called? Oh, a sheep heart. Fifth grade, oh. They let you handle dissection knives in 5th grade. But if you take something like AP biology, which I haven't taken, it's probably a lot worse. Regular biology is not that bad. AP bio, I've heard it's pretty bad. I have taken AP Chem and Physics though, because I still prefer math over biology. Chemistry was all about converting units, and physics was basically a combination of chemistry and calculus. And oh man, if you have units and numbers flying around at the same time, that's double the pain. I do not know what this section is called, but I'm going to call it average. Average value or something. It basically finds the average value of a line on a certain interval. And seems like this will be a pretty easy section. Oh, what is the discovery you made? The interval of -1 to 2. Oh, this feels too easy. This is so refreshing after some physics about pumping water everywhere. So we go from -2 to 2. Like, this anybody can do. As long as you can take the integral. And then you divide it by 3, which is 2 minus -1. This feels so easy. The Catty decided to release a new electric bicycle with a unsay-so name. I think I know what the word say-so means. It comes from Japan, right? It's a Japanese word. That means safe or cool. Was that I'm gonna say pretty strange name. Let's see. What does they name it? Imagine you're biking. Some ask, "Oh, that's a cool bike. What brand is it?" Is it this bike is? I feel like it's not within my restrictions to say that sentence. Are they aware of what that word meant? Because if they did, that would have been a whole different story. Anyways, that was too funny. We got 8 plus 16 times 4 plus 3 I mean, 24 over 3. Oh yeah, bro, I'm just writing food. It's great. That was what I was about to try to suggest, but I don't know if that would be appropriate or not. Oh wait, the second part is even worse. Oh my god. Oh my god. Please do not Google food inflation. It doesn't work. Oh, I think we're good. I think we're good. Yeah, kill Ron is all for it. He's all for the Fuda. Anyways, what a perfect time to find the answer to number 1. At least I think that's the answer. Hang on. No. I did a oopsie somewhere. Yeah. I was so used to be the bottom of the interval being 0 that I forgot we still have to subtract when we plug in -1. So -1 plus 4 is 3 over 3. Which is 7. Okay, how do I time somebody out though? Because I am very unfamiliar with how to use Twitch. Now that I think about it, I actually need to figure out how to time out or all the other different stuff Twitch can do. Especially since the action of using a byte to move is called riding. So that makes it 10 times worse. Yeah, I still don't know how to use Twitch. Or maybe I can't do it inside of OBS. Oh, whatever. We'll move on to the next question, which is going to be number 3. 3 says g of x is equal to 3 cosine of x, and we want the average from the interval -pi over 2 and pi over 2. Twitch stream side sing. Ooh, there's a whole page on chat moderation settings. Your overall safety settings 0. Ooh, you can even put chat rules. I'll figure it out. I'll figure it out someday. Maybe I'll put that as an improvement. Based and red pilled. It just means I don't have any private or red safety setting on. Like, you can't chat unless you have a verified email, things like that. It's not like anybody's gonna hurt me through the chat. It's not like anyone can just telepathically stab me through the Twitch chat. It takes integral and 3 cosine of x dx. And then we divide that by pi. Because from pi over 2 to negative pi over 2 is exactly pi. It's making me hungry. Why does they decide to name the pi? Every time I say it, I can only think of the other circular object that's edible. Maybe one day I'll just put chat moderation as an improvement. And the improvement will just be I can ban people now. And that'll be an improvement for a week. It's pie-shaped. Are circles pie-shaped or are pies circle-shaped? Is that a valid debate? Next, if we take the integral, we get 3 sine of x from pi over 2 to negative pi over 2 over pi. That would leave us with 6 over pi. I don't even have to calculate that. A pi is a circle of pi. But if pi is pi, then what is pi? And we have a full-on scientific claim here. Circles have predated the pi. This is a cross-section of trees with minor imperfections. We have arguments on both sides. We have either pi is the shape of a pie, which implies that to know the shape of a pie, we need to know the shape of a pie, which recurses infinitely, drawing reality to the end. Okay, this is the actual debate now. Have you tasted a circle before? What does a circle taste like? Woodpecker seems to like circles very much if that's the case. But in that case, I just realized a tree would be a cylinder. And then a pie would have the volume of a pie. Because a pie isn't two-dimensional, but a circle is two-dimensional. So pies have an extra dimension compared to circles, therefore pies are better than circles. Anyways, 5 says finally getting worse. E to the power of sine of t times cosine of t. Actually, this is not bad. We want it from the integral, or rather from the interval, not integral, of 0 to pi over 2. Yeah, I can't really taste the circle. You might taste paper and lead, but a pie tastes way better. Anyways, the integral of e to the sine t cos t, that fits perfectly in e to the power of u times du, which means we simply have e to the sine of t if we plug in d for sine t. And we want sine t, e to the power of sine of t from pi to 2 to 0. So we get e to the power 1 minus e to the power of 0, which is 1. And then our interval is going to be 2 over pi. I mean pi over 2. So if we flip that, you get 2 times e minus 1 over pi. I think I just did a terrible explanation. Anyone who doesn't know math gets in here wouldn't know about it. Oh my god. Oh my god. In nature, the circle is everywhere to be found, in the center of flowers, to the cornea of one's eye. I am not one to deliberate if dinosaurs had the ability to create pies, but the point stands. I need to do that in a very narrative voice. 7 says h of x is equal to cosine the first power of x times sine of x from the interval of 0 to pi. Here we have a conversation and a know you. This is a know you of scientific debates. So we want in from 0 to pi of cosine of 4x times sine x dx over pi. Radio. I have not even touched the radio before. You know, I always used to think that AM was for morning radio and FM was for evening radio. Because AM, PM. But anyways, integral of cosine to the power of 4 times x is going to be something about cosine to the power of 5x. It's going to be 1/5 cosine to the power of 5x. And if we take the derivative, yeah, because actually it would be negative. Derivative of cosine x is negative sine x. Wait, in Irish, they don't tickle your feet? Where else could they tickle you? In your armpits? Whatever tickles your Irish funny point. Okay, so where was I? Yeah. From 0 to pi. And over pi. Okay, cosine of pi is -1. So we get positive 1/2. I mean 1/5 plus or minus cosine 0 is 1, so we get plus 1/5 over pi. So we get 1 over 5 pi. And it'll be relating to grass and the height of leprechauns. I need to make a point of researching Irish memes now. I have to know everything. That's part true though. You cannot defeat a Karen with knowledge and power. In that case, the know you meme predates the Karens. Which makes Karens the know you, or rather, it makes Karens the human form of the know you meme. It's your job to do what? To do drugs or to know a lot about drugs? Anyways. Ooh. I don't like 9. Okay, a nurse. Okay, that makes a lot more sense. That makes a lot more sense. I was definitely not thinking anything else. It's 9, 10 both say A. You must first find the average on the given interval. Now, what is a walk heart? Oh, is that a type of drug? Ooh, fentanyl. That's a painkiller, if I remember right. I know basically nothing about drugs except what I learned from a friend who's been playing Drug Simulator 24/7. He knows everything there is to know about drugs. Well, specifically only the illegal type. We'll have to find a C. So this is what, the mean value theorem? And then C, sketch both graphs. Whose area is the same as the area under the graph of F's. That's too long. I'm just gonna write sketch a rectangle. Isn't morphine also a type of painkiller? Or is it not exactly a painkiller? It does some other stuff as well. Easier to take your arm off than to get morphine. I remember something. What was it? About a specific kind of drug getting legalized. Something that to kill people, so doctors can start prescribing people deaths. So they're saying, yeah, no, you're too bad. You're just gonna die. I'm just gonna prescribe you with deaths. How does that work? If it does somehow pass and follow through. Go to a doctor and they give you a prescription for deaths. Damn. So many terms that my brain cannot comprehend. Anyways, we must A, find the average, by which we mean we must first stretch out, or rather FOIL, or little parentheses here. So it takes the integral from 2 to 5 of x squared minus 6x plus 9. Thank you for the follow. I have someone specializing everything here. And divide by 3. Seems about right. Came for the mass, stay for the drugs. Anyways, if we take the integral, get 1 over 3 x to the power 1/3 minus 3x squared plus 9x from 2 to 5. Oh, I have a friend who would love to talk about drugs. I don't know how accurate the game Drug Dealer Simulator is, but he's been playing that 24/7. If he gets out, he's gonna be a drug lord. If he ever gets out of his house, that is. That's why you must never tell him to touch grass. Otherwise, you'll unleash upon the world a type of horror not to be known by men. Actually, I just made a really dumb mistake while talking. There we go, that's better. Oh, now we get algebra again. Time to pull out the calculator. Or rather, it'll probably be faster if I do it by hand than typing everything in. All right. I've seen ketamine in a Kermit meme before, but that's about it. I literally have no idea what any of these names are. As we subtract 122? Can that be divisible by 3? No. Yeah, you know what? Calculator, please. Oops, not that. And that is going to turn out to be 1. Because this is equal to 3. The 0 of 3 is 1. Answer to part A is 1. Wow. We rarely get 1 as an answer. I don't think I've even taken a painkiller before. Wow, we got an actual serious conversation here. This is dark. B. Find C. So x minus 3 squared equals 1. X has to be between 2 and 5, so x is equal to 4. Or it could be 2, but it can only be 4 because, or rather, can we count 2? Because a square bracket is inclusive. I'm not gonna take the risk, I'm just gonna say it's 4 to be safe. C. Now this is the fun part. Graph the thing and the interval. Not the interval. Oh yeah, it's just a rectangle. That's good. So x minus 3 squared, we got a parabola that's moved 3 to the right. No, it's been very entertaining, almost distracting. It's perfectly fine. Raise average value from 2 to 5. 3, 4, 5 would be about here. What a terrible graph. F of x is equal to 1 over x on the interval of 1 to 3. Okay, I need to see if it really is on. He is on. I'm gonna see if I can drag him on. I'm just trying to reach the local drug lord, really. Rhythm games. Speaking of rhythm games, I never really played rhythm games, but I recently got into Beat Saber, which is a VR game, and that is really fun. That is the first rhythm game I played, but man, it is so addicting. I will need a minute. The cat demands entry. I'm back. DJ Max, Tycho, Mustache. I've seen Mustache on Steam, I think. I do not recognize the other two though. A is equal to, or rather, we need to take the integral from 1 to 3 of 1 over x dx and divide that by 2. Can't even tell if this discussion is serious anymore. Okay, really is here. Okay, I need to give him the link to the stream right now. You will love our local drug lord, really. Anyways, let's see. What's the link? Oh man. Let's see if he gets here. I just called for a drug expert. He should be here soon. And so what was I doing? Oh yeah, integral. The integral of 1 over x is going to be natural log of absolute value of x. We don't really care about absolute value since we're only using positive numbers. Divided by 2 from 3 to 1. Okay, he is here. Introducing our local drug lord, really. He knows more about drugs than anyone else on the planet. Okay. Okay, see, he recognizes those terms that I don't even understand. As natural log of 1 is going to be 0, therefore we have natural log of 3 over 2. That's the answer. Yeah, really does a lot of extensive taste tests on drugs to stay safe from them. Is B wants... I don't like B. I don't like B. How do I find a C? Did I even do this right? Let's pull out the calculator for this. Okay, we're relating the drug discussion back to math now. Oh my god. Okay, focus. Let's see. They do have a deadliness rating on drugs, right? Like, how deadly is a single drug? I remember really mixing the deadliest drug with the second deadliest drug. In natural log of 3/2. Hang on. I had math wrong? Did I? No, I didn't. Oh man, how am I gonna go about calculating this? Oh, actually, I am stupid. Because if natural log 3/2 is equal to 1/x, then x is equal to 2 over natural log of 3. Therefore c is going to be equal to 2 over the natural log of 3. Anyways, now we get to graph the function. A 1/x graph looks something like this. And if we just say, oh man, 2 over the natural log of 3 is almost 2. Almost 2. So we'll say it's about right here. And that's like 1 to 3. What a terrible graph. Ooh, we made it to the same lens as 6.4 already. Making some good progress. Onward to 13. Get off, get off. 13 says if f is continuous and over 3 f of x dx is equal to 8 shows that f is equal to 4, or rather f of x is equal to 4 at least once on the interval from 1 to 3. Yeah, how dumb does flavored air sound? man, how do we get to from just the silent room to suddenly a discussion on drugs? I still don't get it. How do you just turn from a chill and safe stream to suddenly drug discussion and torture by calculus? And I still have no idea how to solve this thing. F continuous shows that f takes on the value for at least once. Okay, mean value theorem. 3 minus 1 is equal to 2. Therefore, the average. Let's make that a subscript. Wait. If flavored air is like a scent, and flavored air is vape, does that mean perfume are vape? Perfumes are drugs, guys. Yeah, so the average is going to be this integral divided by 2, which is equal to 8 over 2. Is equal to 4. And by mean value theorem, I think that's the one. We got mean value theorem, intermediate value theorem, and what other value theorem? I cannot remember all of them. By the mean value theorem, the average, if the average, how do I word this? How do I word this? F of x will be 4 at least once on the interval from 1 to 3. I think that's satisfactory. On to 17, and I just realized that I got the colors wrong again. Fantastic. Blue. My answers must be blue. And you got another weird question, another long word question. Temperature in Fahrenheit T hours after 9 a.m. My writing just keeps getting worse and worse. Is modeled by the function which is t of t is equal to 50 plus 14 sine pi t over 12. All right, now says find average temp between 9 a.m. and 9 p.m. Ouch. writing for too long. Okay. Now 9 p.m. comes 12 hours after 9 a.m. So we want the integral from 0 to 12 of 50 plus 14 sine 5t over 12 dt divided by 12. That would be the average temperature. Now we just gotta do the calculus portion. If we integrate 50 turns into 50t plus 14 sine turns to cosine pi over t times 12 times derivatives inside, which is pi over 12 from 0 to 12 all over 12. I don't like this. It's time to pull out the calculator. 50 times 12. Imagine if a calculator or the hidden function of the calculator so it can call 911. Or rather, if you type in the wrong equation, it calls your teacher. And then they deduct your grade. That sounds terrible. Anyways, where's pi? Here's pi times 12 divided by 12 times pi over 12. This equation does not even fit in the calculator. No, that's not a pi, that's e. Here we go. Oof. I do not like this. But one thing that's conclusive is if we plug in 0, that's equal to 0. Wait, no, if you plug in 0, it's not equal to 0. Let's put that in the calculator. Looks about right. That's 300. That doesn't look too right. There's a problem somewhere. Where's my problem? "9 a.m. and 9 p.m. It's 2 hours after 9 a.m. It is 12 hours. So why doesn't this work? My integral is incorrect. Or rather, I think I know what it is. Temperature is going to be at least 50. 50 is like our baseline. We can take 50 out and it will be 50 plus. So integral from 0 to 12 of 14 sine pi t over 12 dt. And that would be divided by 12. Let me try that to make sure it's correct before I do anything else. Sine pi t 12 from 0 to 12. Actually, let me just integrate. 50 plus, or wait, hang on. My color. Every single time. T plus turns into 14. Wait. Integral of sine is negative cosine. Was that where my problem was? Shouldn't be though. Negative 14 cosine times, no, negative 14 cosine of pi t over 12 times pi over 12. No, I just realized 12 over pi, not pi over 12. But then this is negative or positive. Looks about right. But that 12 cannot cancel out. I need to remember that. Put that in parentheses. This is from 0 to 12. So we get 50 minus 14 times cosine of 12 pi over 12. So cosine of pi times 12 over pi. Or rather, cosine of pi is negative 1. Let's take the 14 outside. Cosine of pi negative 1 minus 0. Cosine of 0, 1. And then needs to be divided by 12. That doesn't make sense either. Where else did I make a mistake? Wait. Did I do something dumb again? I didn't multiply by 12 over pi. 14 times pi cosine pi negative 1 over pi minus 1 over pi. But that's still a no. Wait, it works. 50 minus, or in this case, plus 14, that's negative 2, so 28 pi, 28 over pi. 50 plus 28 over pi Fahrenheit would be the answer. There we go. And that concludes unit 6.5, which is a pretty easy unit, all things considered, and leads us to the most painful of them all, integration by parts. Oh, I remember doing integration by parts way back in high school. It was a nightmare. Oh god, did I just accidentally draw something? No, I didn't. Okay. I need to make sure it lines up, so about starting a new line, a new column about halfway through here. 7.1 integration by parts. Okay. Before I get started, however, I really need a little break. So I'll be back in like 3 minutes. We'll be back after this quick commercial break. Alright, I'm back for one last round of torture before I go for the day. Number starting from 11. Actually, I should probably first start by saying that integration by parts follows only one basic formula. It's the integral of u dv is equal to u times v. That gives a u a little tail so we can differentiate it from the v, minus the integral of v du. This will make an integral that's not normally integrable to one that might be more manageable. A hard word is might. Because not everything will still be integrable. Sometimes they get into an endless loop or have to do a bit of subtracting and or rather adding to both sides and then dividing. Sometimes it still just doesn't work. But this is very painful because integration by parts is a long process. 11, for example, nothing's better done than by an example. The integral of t to the power 4 natural log of t dt. Now if we just try to integrate by hand, there's no way we'll be able to integrate that. For that, we need to pick out a u and a v. For this example, L and T is the part that's hard to integrate, so rather it'll be easier to do natural log of t. So I'm gonna say that u, let's put it over here actually, u is equal to natural log of t dv is equal to t to the power of 4. You can see that in the formula t fits into uv, ln t, natural log of t fits into u. From that we can then find our u and v. du is going to be 1 over t and v is going to be 1 over 5 t to the power of 5. Now we can plug it into the formula, which will give us the very long result of 1 over 5 t5 natural log of t minus the integral of 1 over 5 t to the power of 5 times du, which is 1 over t, which would give us t to the power of 4, which is very clean. So 1 over 5 times t to the power of 5 natural log of t minus 1 over 5 and times the integral of t to the power of 4, which once we integrate that, I'm just gonna write out the front part for the first question and then I'll just skip those to make things faster. We get minus 1 over 25 t to the power of 5. And of course, plus c. It's a constant of integration. For any indefinite integral, we need to remember to put plus c. Alright. That is not so difficult one. Next up, we'll get into one with trig identities. This one says it wants the integral of t times the cosecant squared of t dt. Okay. I probably don't want to take the integral of cosecant squared. I'm gonna say or u is equal to t. and dv is equal to cosecant squared of t. That way, we have a constant for du, which makes things a lot easier. And if we integrate cosecant squared of t, it would be negative cotangent of t. Now that I think about it, some of these problems I might have done before from Mass 180, because the first stream I ever did, which I don't think I've even archived, was on integration by parts. And it was a nightmare. It was like 30 questions, all integration by parts. So I remember how to do these pretty well. Anyways, u times v, we get negative t cotangent t. Okay, 1 second. The cat demands the usage of the door. The cat has been granted passage. Okay. Where was I? Negative t cotangent of t. Zoom in a little. Why was I so zoomed out? And it's gonna minus the integral of v du. So since du is 1, we simply have negative cotangent of t dt. And then, oh god. So this is negative t cotangent of t plus cotangent t dt. Okay. Cotangent of t. There was an identity for it. The integral cotangent of x is equal to, I think, natural log sine of x. Or was it negative or positive? Natural log sine of x. I think it's positive. So that will end us with negative t cotangent t plus natural log of sine of x plus c. A bit more confusing. If you don't remember this, I think you can just multiply it out. Like if you do cosine over sine, and then you do an integration by parts here, we have, instead of that, you have cosine times 1 over sine. If you just do another integration by parts with cotangent, you can eventually reach natural log sine of x. Because if you take the derivative of natural log sine of x, you get 1 over sine of x times the derivative of sine of x, which is cosine of x. So it does work out. Next up, we got 17. 17 says, and I hate this, how's my font size compared to the rest? Okay, our font size here is clearly way bigger. I was not at the same level of zoom. I don't know if we can fix that, it's probably too late already. But number 17 wants the integral of e to the power of 2 theta times sine of 3 theta. D theta. Oh man. How am I gonna do this? I think this is one of those problems that recurses infinitely. Right, but anything we pick would work. Let's just say for this problem specifically, it doesn't matter what you pick for u or pick for v. You will inevitably reach the same conclusion that this problem sucks. Actually, I want to take derivative of the sign because it just feels a little more intuitive, even though it's basically same thing. That would be 3 cosine of 3 theta. V would be, oh, this is e to the power of 2 theta. Would be 1 over 2 e to the power of theta. No, to the power of 2 theta. Keep forgetting to write that. And if we do or u sub, by the way, if you forget the order of uv substitution, integration by parts, you just draw a little n between u, du, v, and dv. So it's the integral did I put it in the right order? Did I put these into the wrong order? Yeah, I put these in the wrong order somehow. It doesn't actually matter, it just... if you order your things this way, where it looks a little more confusing, you have an easier time if you don't remember the formula for UV substitution, because you would be able to draw a little n here. The other two problems are messed up. Like, the order of u, du, v, dv is wrong. I just remember the formula. Oh, but yeah, integral of u dv, or first little thing here, is equal to u times v, the second line of the n, minus v, the integral of v du, the third little line. Zoom back in, and we do our little substitution. 1 over 2 e to the power of 2 theta times sine of 3 theta minus the integral of 3 over 2 e 2 theta cosine 3 theta. Now we'll end up with something that looks pretty similar to what we started with. In this case, we gotta do integration by parts again. So this time, let's pick our u to be cosine of 3 theta. And that means du will be the negative 3 sine of 3 theta. dv will still be e to the power of 2 theta, and v will be 1/2 e 2 theta. So in total we would get 1 over 2 e to the power of 2 theta sine 3 theta minus 3 over 2 times uv 1/2 cosine of 3 theta. Alright, so let's do v first. 1/2 e of 2 theta times cosine of 3 theta minus integral of, or plus integral of 3 over 2, because it's negative sign here, we pull the negative sign out, And you would notice we have e to the power of 2 theta times sine to the power of 3 theta d theta. Looks pretty familiar, doesn't it? Hello, 24 Gunner. Welcome to the suffering. And if you can see the chat history, you can see a long-winded debate about drugs. Yeah, I don't know what we're doing here. But we are left with the same integral we started with. If we keep doing the UV substitution or integration by parts, we're gonna be stuck in an endless loop, forever unable to reach the truth of finishing the question. But because we ended with what we started, it enables us to do a little more than that. Let's first factor out some fractions. Minus 3/4 e to the power of 2 theta times cosine 3 theta minus 9/4 and the integral of e to the power of 2 theta sine 3 theta d theta. And we didn't actually write the complete equation here. If we write the complete equation, it will look like this. So integral of e to the power of 2 theta times sine of 3 theta d theta is equal to this long c. That means we can move this back to the left side. So if we add 9/4 and the integral of this thing, this monstrosity, to both sides, we would end up with 4 plus 9 13/4 times e to the power of 2 theta sine of 3 theta d theta is equal to, you'll see in a moment, 1/2 e to the power of 2 theta sine of 3 theta minus 3/4 e of 2 theta e to the power of 2 theta cosine 3 theta. And now if we just move the fraction to the other side, we get the integral of e to the power of 2 theta sine of 3 theta d theta is equal to 4/13 times over 2e 2 theta sine of 3 theta minus 3/4 e to the power of 2 theta times cosine theta. And writing it in words by the minute. Thank you for the follow. Every number counts in the game of math. And this would be the answer. We're no longer stuck in the infinite loop of integration by parts. We simply need to do it twice. Oh my god, that was long. Anyways. Rather, this is the right one. Yeah, I just didn't simplify this. Alright. Forgot one key thing. This answer is wrong because I forgot one thing. And it's a very simple thing. Oh no! That deletes. Okay, undo still works. Draw a little m back. Because I forgot plus c. Yes. We do this every Saturday. We put ourselves through torture. But hey, we're almost done today. You only have to suffer with us for a little bit longer. That is 17. Next up we have number... Ooh, jumping around here. Next up is number 29. And 29 says... it wants the integral, a definite integral from 0 to pi of x times sine x cosine x. Oh no. Every time I have too much things on the whiteboard, it starts lagging. I'm thinking about doing every unit on a separate board now. Okay, in UV substitution, this is gonna involve a particular formula. Because, if you didn't know, sine x times cosine x is equal to 1/2 sine squared x. That's a formula. And for this one, I think we want to pick the u as the easy one. So we have x, so therefore du is simply 1. That means our second integral will definitely be integrable. Or able to be integrated. I don't know if integrable is a word. dv, therefore it's going to be 1/2 sine squared x. And dv will be, or rather v. Oh my god. This is really the right choice. I think we don't have to use the formula. Might be easier this way. Because of dv is sine x cosine x. That follows the formula of u du. Therefore, v can be equal to sine squared of x. I think my notes was wrong. This is what it was referring to. That was not a formula. That was the integral. I think I've done this exact problem before, and that's where I had my notes from. So forget that part. X, sine x cosine x is not equal to 1/2 sine squared x. It's just 1/2 sine squared x is the integral of that. Anyways. I'm pretty sure I've done this exact problem before. Yeah, whatever. Now we have 1/2 x sine squared of x minus the integral from pi. Totally forgot it. Yeah, you should probably go. This doesn't really help with anything. Have fun with your dream. I'll keep suffering here with my calculus. Alright. Now I have VDU. Let's put the 1/2 out here, so it's sine squared x dx. I might have just made things worse. Oh no. Let's see. Sine squared x. What is the formula for that? 1 minus cosine squared of x. Can I integrate that though? Maybe I picked the wrong U and V. What if I picked the other way around? That wouldn't be any better. Give me a moment. I don't remember the reduction formula. Wait a second. I just realized something. I wrote down the wrong formula. I am not in the correct mood to do math. There's an easier way about this. I wrote down 1/2 sine squared x later. That was wrong. Sine x cosine x is equal to 1/2 sine 2x. Forgot what that formula's called. But that would make things a whole lot easier. So we got 1/2 sine 2x, and v would be equal to 1/4 cosine 2x. Negative. Yeah. And that would mean we end up with negative 1/4 x cosine of 2x minus the integral of or plus 1/4 integral of cosine 2x, which would be one half sine of 2x. And we want all that from 0 to pi. Oh man. Cosine 2 pi is 1. So we get negative pi/4 plus sine 2 pi is 0. Sine of 0 is 0 too. So we get negative 2 pi minus cosine of 0 is the same thing. Wait, no. If x is 0, both of these are 0. So we're left with negative pi/4. Let me check. Sine of 2 pi and pi are both 0, yeah. Gone. This is correct. Yes, the calculator gives me the approval. Calculator says yes. Therefore, we must trust the machine. We got quite a few left to do. Moving up next is number 30. Number 30 wants to know the integral from, what is this, 1 to the square root of 3 of arctan. Let's just call it A10. Of arctan of 1 over x. So we can rewrite that dx. Okay. A10 of 1 over x. There's only one part to this though, so if the unit's about integration by parts, one of them has to be 1. So first let's rewrite that. From 1 to square root of 3 of arc cosine. No. Arc cotangent of x dx. Now that's a lot easier to read. I have to pick my u. Actually, we can't even pick. Our u has to be arc cotangent of x, and our v or dv has to be what? It's not a choice. It has to be this way. Then du, if you take the arc cotangent, that is negative 1 over 1 plus x squared. You just have to remember that, trig identities. And the v is equal to x. Alright, moving on. Move down a little. Not that way. Wish there's a better whiteboard. Let's see. UV substitution. X times arc cotangent of x minus the integral of v du. Let's put the negative up here. Actually, no, we can't do that. We can't do that. Can we? Yeah, we can. So this is x over 1 plus x squared. Okay. Dx. Alright, this integral is manageable because we would need natural log of 1 plus x squared. So that would turn out to be 1/2 natural log of 1 plus x squared. Oh my god, and this is a definite integral. So we have x times a cotangent of x plus that from 1 to root 3. Is this even possible by hand? Alright, time to bring out the calculator. I do not want to do this by hand. The integral is correct. That means all that's left is numbers. And I hate this. root 3 a cotangent root 3 plus 1/2 natural log of 4 minus a cotangent of 1. No. I forgot how to do arc cotangent. How does arc cotangent work? Sine over cosine. No, the other way. What's our cotangent of root 3 then? Nowhere is a graph root 3 over. Or not one I can remember. But our cotangent 1 is going to be equal to pi over 4. That is 45 degrees. Where sine x and cosine x are equal. Why did I write 5? Pi over 4. Plus natural log of 2 over 2. No, please. Now the question is, have I made a simple typo somewhere? Because they always get to you. Compared to the simplified counterpart, this looks... surprisingly kind of correct. I will say that's the answer. And well, the actual value is like 0.468075 something. So next up, we have 31. Which is the integral from 1 to 5 of m. That's the first time I've seen the variable m used over e to the power of m. Okay, so I can rewrite this to m times e to the power of negative m. And I have to pick, I want my u to be my easy variable, because if you take a derivative or integral of e to the power of negative m, that's going to repeat forever. So our u must be m, and du would in turn be 1. dv has to be e to the power of negative m, and v would in turn be negative e to the power of negative m. If we do that, we're left with negative m e to the power of negative m minus the integral of, or plus integral of e to the power of negative m. So negative m mz to the power of negative m plus, oh, and that's from 1 to 5. Might have forgotten to write that in places. This is all from 1 to 5. 1 minus e to the power of negative m. These are all from 1 to 5. Could probably simplify that a little to negative e, negative m plus 1 And that will leave us with one plug 16 -6 e to the power of -6 plus e to the power of -1 times plus 2e to the power of -1. Actually, go. I made a little mistake here. This is not e to the power of -6. It's -5. Because e to the power of m is 5. This part's m plus 1, so that's why that's 6. Alright, I think that is the solution. Not as hard as it looked. Bring us on to 32. And 32 states that it wants to integral from 1 to 2 of, oh boy, this might be the worst one we had so far. Natural log of x squared over x cubed dx. Now I'm wondering, would it be possible to use a tabular method? The tabular method is actually something somebody else taught me on the stream when I was still in Maths 180. Someone told me on stream that I could use the tabular method, and I wonder what that one was. And now I know. So I have UV here. I think this is how it goes. I want my U to be natural log of x squared. And my V to be x to the power of -3. We take the derivative of U 2 times is this the right way? 2 times natural log of x over x. What's that work though? How would we quotient rule? This problem will take 2 steps regardless. So it might be easier that we don't do the tabular method. If we go the normal route, we get u dv. U will be our natural log x squared. dv would be our x to the power of -3. V would be -1/2 x to the power of -2. du would be 2 natural log of x over x. Everything works out. Great. So we get -1/2 x to the power of -2 times the natural log of x squared minus or plus 1/2 2 times natural log of x over x cubed. X to the negative power, like x to the power of -2 just 1 over x to the power of 2. And I think I see how this one goes now. So we need to do another UV substitution. Or actually, if we take the 2 out, that cancels with the 1/2. Where u is going to be natural log of x, du will be 1 over x. dv is x to the power of negative 3, and v is 1/2 x to the power of negative 2. Ooh, dx. I always forget to write things like that. And we end up with negative 1/2 x to the power of negative 2 natural log x squared plus, here's where the fun starts, 1/2 natural log of x, 1/2 x to the power of negative 2 times natural log of x minus, what's this, 1 over x cubed. Or rather, this should be negative, so plus 1 over x cubed, or x to the power of negative 3. And we already know that the derivative, or the integral of x to the power of negative 3 is negative 1/2 x to the power of negative 2. So, this is why I don't like this section. It's not difficult by any means, it just takes a long time. It's like you're grinding in a video game. And this would all be from 1 to 2. I do not want to do this by hand. Why must they throw me problems like this? Double check, nothing went wrong. Hang on, I think I spotted a problem. Negative, right? Because 1/2 x to the power of negative 2 is negative. That was positive, now it turns negative. Okay. Plugging numbers. Negative 1 over 8. Natural log of 2 squared. Actually, could I have just turned that to 2 natural log of x? No, that's not how it works. Okay. Minus 1 over 8 natural log of 2 minus 1 over 8. No, plus. I feel like I could have factored out a lot of things. Yeah, I definitely could have. Oh, we're too far down this path. Yeah, you know what? I'm gonna factor first. Let's see. How about negative 1/2 times x, or natural log of x squared over x squared minus, or in this case plus, natural log of x over x squared. Everything can be over x squared, or rather divided by x squared. So negative 1 over 2x times its natural log of x squared plus natural log of x plus or minus 1 from 1 to 2. That looks a little bit cleaner. Okay, negative 1 over 4 times natural log of 2 squared plus natural log of 2 minus 1. And all that minus, let's put square brackets to differentiate, just so I can tell which one's which. Negative 1 over 2. Natural log of 1 is 0. So times negative 1. So that's just plus 1/2. So in the end we get negative natural log of 2 squared plus natural log of 2 minus 1 divided by 4 minus 1/2. Or rather, minus 2 over 4. Like that. Now is this the answer? I don't know. This is an even numbered question, so I cannot check the answer. I'm just gonna hope that's the answer. Or actually, what if I have my calculator do it? Well, I'm gonna take a minute here. I need to know. I need to know whether I did something right or wrong. If everything works out correctly, the answer would be around 4.08 times 10 to the power of negative 2. What about my answer? Actually, hang on. No, can't go back. Let me do. I have to type all that in again. Let's see. Ah. No. Oh, I see. I see. I forgot to write x squared. We factored out x to the power of negative 2. So this would turn out to be 8. Well, this would be 4. And would that turn out to be 4? No. Side effect would not turn out to be 4. Because it's still 1 over 2 because we plugged in 1. So this here would not be 3 either. Of course I had to make a little mistake. Good thing I checked. So that would be 4 over 8. Which means this is negative 5 over 8. Right? No? Let's see. Where does this go? Where is this? I don't even know. Let's calculate my answer. Something's wrong somewhere. So where? Something's wrong here. Was I missing parentheses somewhere? Oh, I used x to the power negative 2 instead of negative 1/2 x to the power negative 2. There should have been a 1/2 here, and that would turn out to be 1 over 4. Which would mean... it's just because I forgot about the 1/2 that this entire thing's wrong. It's okay, we can still correct this. Carefully wipe out the 1. It's good. This, if that's a 4, then instead of 1, this would be 1/2. And this would be 1/4. And if we factor in that, we would get this over 8. That would be 2 over 8. So minus 1/2 plus 2 plus 3 over 2. Let's try that. Calculator, go. That's so long. And the answer is nope. Big fat nope. Hang on. This is the exact same integral it is. Plug in 2. You get that. Plug in 1. Get negative 1/2 times negative 1/2. Uh, wait a second. Negatives. Because that's negative. That would turn out. Ah, this is messing with my head. There's a negative out here. That was the problem. If we take into consideration this negative, it would be plus 3 over... No. Minus... What? Minus 3 over 2 instead, right? Oh. What was it I had? Did I have this answer? This is a point in time where my brain just stops working completely. Yeah, it is! When you put the value into the calculator, they turn out to be the same. Yes! That was the answer. Oh my god. This is so tedious. But we're almost there. The bad part is every problem's only gonna get harder by the time. So we want 33 wants interval from 0 to pi over 3 of sine of x times natural log cosine of x. We're stacking natural logs with trig identities. My god, this really does get worse. Okay. U. What do I want my U to be? Let's have my U be sine of x. I don't know which one would be easier. Take natural log. If we integrate, we get some weird thing. If we take derivative, we get 1 over cosine of x, so secant of x. Secant of x doesn't sound that much better. I'm gonna try with sine of x first. Du would be cosine of x. And we have dv being natural log. Was it absolute power? No, it wasn't. Cosine of x. The v would be equal to... This is ln x, so x ln x plus x. Or no, minus x. Yeah, that doesn't look better. That doesn't look better at all. That looks way worse. Change of plans. U shall be natural log cosine of x. D will be 1 over cosine of x times negative sine of x. So effectively, negative tangent of x. dv will be sine of x, therefore v will be negative cosine of x. And that looks better. We have negative cosine of x, natural log cosine of x, times, or rather, if that part's right, minus the integral of 10x cosine of x. Dx. Two negatives cancel out, looks like it. So that would be the same as the integral of sine x over cosine squared x. Oh god, my brain suddenly stopped working again. What was it I wanted to do? Oh yeah. So that would turn out to be cosine. If I write negative 1 here, that would look like arc cosine. I was fine differentiated that. If it's arc cosine, would have a cos. So if it takes a derivative of that, negative, this had to be negative cosine of x, then cosine squared of x, no, cosine of negative squared x, times derivative cosine of x, which is, so would just be cosine x to the power of negative 1. Oops, not 2. Let me test out real quick. Negative cosine x to the power of negative 2 times the derivative of what's inside, so negative sine of x. That works out. That will give us negative cosine of x, natural log cosine of x, minus secant of x. And we want that from the interval 0 to pi over 3. Why? Okay. We calculated it just in case everything doesn't work. Power 3 cosine power 3 cosine y, so that would be 1/2 negative 1/2 natural log of 1/2 gone. Something's off. Where did things start going wrong? My integral is incorrect. I calculated. Oh, wait a second. I just did something really stupid. This is not cosine to the negative first power of x. This is... can't believe I did this. This times cosine x, so that cancels out. Why? Oh my god. Then that would just be equal to negative cosine of x, which means it would have to plus cosine of x. That makes a lot more sense. And let's simplify this a bit, because we got cosine of x everywhere. So cosine of x times factor out cosine of x 1 minus natural log of cosine of x. So cosine power over 3, which is 1/2, times 1 minus natural log of 1/2 minus plug in 0, cosine of 0 is 1, natural log of 1 is 0, so plus 1. How's that answer? How does that compare? We punch the numbers in. Huh. Just making sure cosine of pi over 3 is 1/2. Right? Yeah. So this 1/2 minus 1/2 natural log of 1/2 plus 1. That doesn't look right. My integral's correct. So this is an algebra problem, algebra mistake. If I punch it in my calculator. Where did my math go wrong? One minus natural log of 2. Or rather 1/2. Huh. Get a negative number. There's definitely nothing wrong with my integral. God. Think I know the answer. Let me double check to make sure. Yep. Natural log of 1/2 is equal to natural log of 2 to the power of negative 1, which in turn is equal to negative natural log of 2. That still doesn't explain why my number's wrong though. So let's say we have 1/2, 1 plus natural log of 2 minus 1 times 1 minus natural log of 1's minus 1. So we got, that would be 2 over 2 natural log 2 minus 1 over 2. That makes a lot more sense. It's natural log properties. Somehow didn't recognize that at first glance. Well then, once we're done with that is 33, scroll down to 35. "35 wants to know the integral between 1 and 2 of x to the power 4 times natural log of x squared." Okay, this one I think we can do tabular, because both of these can be reduced pretty much infinitely. And of course dx. So we have u here and v here. Let's have our u be natural log of x squared, because I already know pretty much the derivative for those. And v can be x to the power 4. Take derivative once, we get 2 times natural log of x over x. Oh wait. Yeah, how did I do it before? so we would not have access to this yet. Yeah, no tabular. Back to the boring old ways, which will also take very long. Actually, let me try something. Notifications. Yeah, no. We're doing this the old way. Alright. Starting with taking our u's and v's. My u's still gonna be natural log of x squared. It's kind of the same as another problem we did, just even longer. dv will be x to the power 4. du will be 2 times natural log of x over x. And v will be 1 over 5 x to the power 5. Following uv substitution, we get 1 over 5 natural log of x squared times x to the power of 5 minus c integral of 2 over 5 natural log of x over x to the power of 4. Now we're back. Take uv again. U is natural log of x. du is 1 over x. dv is x to the power of 4 or negative 4. Wait. Just realized my mistake. If that's the case, this would be negative. So that would be negative. And this would be positive. There we go. And d, not d, just v would be equal to negative 1 over 5 x to the power of negative 5 again. So this would be that plus 2 over 5 times negative 1 over 5 natural log of x times x to the power of negative 5. Oh yeah, this is negative 5 minus the integral plus the integral of plus 1/5 times the integral of x to the power of negative 4. Alright, so we get, stretch everything out. Equal to 5 natural log of x squared times x to the power of negative 5 plus 2 over 25, or rather not plus. If we factor everything out, this should be minus 2 over 25 minus, draws a little mark, natural log of x times x to the power of negative 5. We can probably factor out x to the power of negative 5. And then this is going to be plus 2 over 25 times, or in this case, So that would be -1/5 x to the power of -5. So that would still be minus. So this would be -125 times x to the power of -5. And we want all that from 1 to 2. As a condolence, we at least have simple numbers. And do I want to factor everything out? X to the power of -5. Or we could say -1/125 x to the power of -5 is equal to 25 natural log of x squared plus 2/5 natural log of x plus 2 from 1 to 2. Not the numbers again. Alright, we don't even have enough space on one page. Plug things in. Oh. Natural log of 1 is just 0. So in here we simply get 2. 2/125. That doesn't really make things easier for me, does it? Actually it does, but I don't want to have to calculate out all this by hand. Let's see. -1/. I probably made some algebraic error here and there. 2 to the power of 5 times 25 natural log 2 to the power of 2 plus 2/5 natural log of 2 plus 2 parentheses n plus 2/125. Yeah, no. I still did something wrong. But what is it that I did? Wait. Oh no. I was right the first time around. This is always... Ah, why didn't somebody tell me? This was... lag. This was x to the power of 4. I thought that was divided by x to the power of 4 for some reason. That was supposed to be positive. We get to do this again. Fantastic. That'd be 1/5 x to the power of... Even if that wasn't negative, I would still have gotten... I mean, if that was negative, I would still have gotten the whole thing wrong because I did this integral wrong. So we get that. And we will end up with 1/5 natural log of x squared times x to the power of 5 minus integral of 2 over 5 times natural log of x, rather x to the power 4 natural log of x. Do the same thing, u equals natural log of x, du is equal to 1 over x, dv is equal to x to the power 4, v is equal to 1 over 5 x to the power 5. Now we get minus 2 over 5 times 1/5 natural log of x times x to the power 5 minus the integral from, ooh, it ran out of songs to play. Played through the entire playlist already. Oh, we'll have to go again. Minus, what am I minus? Okay. 1 over 5 integral of x to the power 4 dx. Dx everywhere. So that will lead us to 1 over 5 natural log of x times 2 times x to the power 5 minus 2 over 25 natural log of x times x to the power 5 plus 2 over 25 times 2 over 125 times x to the power 5. That in turn would give us 125 x to the power 5 times 25 natural log of x squared minus 2 times 125. Hang on. What just happened? What am I thinking of? 5, 10 natural log of x times, no, just 10 natural log of x plus 2, and that would that be it? Oh, hang on. Not 125. 1 over 125. That's what I factored out. And that would be right. So now we just want that from 1 to 2. Get 2 to the power 5. 32 over 125 times 25 natural log of 2 to the power of 2 minus 10 times natural log of 2 plus 2 minus 1 over 125 times 2. So minus 2 over 125. Fantastic. I do not wish to simplify, so I'm gonna just check if the numeric value matches. Minus 10 natural log of 2 plus 2 hang on, minus 2 over 125. Numeric value matches. I'm good with this answer. I don't want to simplify. And I'm gonna need to excuse myself for another moment here. I have returned. And music stopped playing again. Why is that? When does it stop? Alright. Well, while we're figuring that out, we have completed 35. Actually, I can write down the simple answer, the simplified answer for this one. It's an odd number question. The answer is in the textbook. But I'm fine with not simplified. Calculus is cool, but algebra, I hate algebra. Maybe it's just because I've done it so many times that it just gets boring. Even a game like Elden Ring, if you can play nothing but Elden Ring for like 10 years straight, you would still end up bored. Anyways, that is not a cotangent. 40 wants the integral from 0 to pi of e to the power of cosine of t times sine of 2t. Interesting. We need a double angle formula. dt. Interesting. How would I solve this problem? If we do integration by parts, cosine of so that would be really annoying to deal with. I might know a faster way to deal with this problem than integration by parts. For that, if I take out the double angle formula, was it -2 sine? Let me just check, double check. It should be negative sine t cosine t. No, -2 sine x cosine x is equal to sine of 2x. Sine of 2x, double angle formula. No, I was wrong. Why did I say negative? Yeah, why did I say negative? Okay. If we rewrite this as integral from 0 to pi of e cosine t, takes the 2 out, cosine t sine t dt. And actually, if we say u is equal to cosine of t, this would be u times eu times negative du. Would I be able to work with that? Because if it's a case like this, integration by parts is easy. What I just did was that negative. Is that allowed? Let's say we have -2 from 0 to pi of that. If I had negatives both in and out, then yeah. Because if we just add a negative in there, this would be times negative sine x or sine t. And that would work. And then by u sub, u is equal to u, du is equal to 1. I shouldn't have picked u, that was a bad choice. dv would be equal to eu, and then v would still be eu. This way, we get -2 times u eu minus integral of eu, which is eu, which is equal to -2 times, plug u back in, cosine of t times e to the power cosine of t minus e to the power of cosine of t. Can I simplify that a bit? Yeah. -2 as let's say 2e to the power of cosine of t times 1 minus cosine of t. I think that's the easiest I can get it, from 0 to pi. Cosine pi is -1, so we get 2 over e times minus 2, so 4 over e basically. Did I forget something? No, I did not. Minus cosine of 0 is 1. We get 2e, no 0. So we get 4 over e. Is that right? I'll just... I need to check this answer a different way. This is an even number question. Max. I need to know. It is correct. Oh my god, I got this one right on the first try. Anyways, once number 40 is complete, we scroll down to number 43, which asks for the integral from... Actually, it's an indefinite integral of x times e to the power of -2x. Okay, that's not bad. There's only one right choice here. U is gonna be a polynomial. du is equal to 1 clean. I like it. dv is gonna be equal to 1 over... No, e to the power of -2x. And v is gonna be -1/2 e to the power of -2x. Yes. And integration by parts. We get -1/2 x e to the power of -2x minus, or in this case plus, 1/2 e to the power of -2x, which is a -1/2 e to the power of -2x. So we get -1/2 x e to the power of -2x plus or minus 1 over 4 e to the power of -2x plus c. And is that it? Oh, it also wants you to graph it. No wonder. Of course it's not gonna be easy. So let's try and draw a graph. Oh god, how to graph x times e to the power of negative 2x? Let's see, as x approaches 0. Oh no. As x approaches 0, y approaches 0. As x approaches positive infinity, y approaches 0, because the speed at which exponents grow is higher than x. As x approaches negative infinity, y approaches negative infinity. So we got something that looks like this. It's gonna go this way and it's gonna go down to 0. And it's gonna just keep going down. That's what this function will look like. But what about this abomination? Can I simplify this? Oops, deleted that too. Simplify this, factor out. Negative e to the power of negative 2x times x times 1/2 x minus 1/4. As x approaches 0, y approaches. Wait, I'm getting something wrong here. This 0, e to the power of 0 is 1, negative 1 times, so we'll get 1/4. As x approaches 0, y approaches 1/4. This, no. Shouldn't this also be 0 though? Wait, this is a plus. Because that's a plus, it approaches negative 1/4. I think we need a slightly better graph for this. Let's make a bigger one. For the first function, it goes like this. Then downwards towards infinity. Here it approaches the x-axis. Our second function starts at y goes negative 1/4, so negative 0.5. As x approaches infinity, y approaches 0 again. So approaches 0. As x approaches negative infinity, y approaches positive infinity. So it's kind of like these two are mirrored. Goes like that. Oh my god, what a terrible graph. But it gets the job done. I'm not gonna stress over some graph. I hate graphing anyways. This is onwards towards positive infinity, onwards towards negative infinity, to 0. This is 0, negative 1/4. This is 0, 0. We'll call that it. After 43, we got another graphing problem, which is 45. 45 wants the integral of x cubed times 1 plus x squared. Okay, how do I approach this problem? We got dx. I don't know how many dx's I forgot over the course of this recording. I think I got most of them though. What do I do? I've done a problem kind of like this before. It was also approached with u sub instead of integration by parts. Or was it? How do I do this? Let's see. Integrate or take derivative. Both sound pretty bad. Is there identity for this that I don't remember? 1 over... that was for... cosine? Let me check. No. What was this for again? I remember seeing the summer. Oh, that was 1 minus x. So how's this one done? And to finish all off with a low battery warning. I can take the derivative x to the power 3, but can I really integrate this thing? Can you use sub? Brains completely stop working by this point. Nope. Can multiply everything in. Like, hang on a second. No, that's not viable. Uh, my God, how do I do this? Let's see. I actually do not know. Or rather, my brain doesn't want to tell me. Might help if we graph it first. So try to do just that. Put the graph down here. X approach 0, Y approach 0, X approach positive infinity, Y approach positive infinity. It's a cube function, so it probably looks something like this. Y approaches negative infinity, X also approaches negative infinity. So kind of like a normal cube root function, but weird. You get the point. How would this work? Alright. Time to get some help. Wait a second. So looking at another problem I did like a year ago, almost exactly a year ago, or was it? Was it half a year ago? It was x cubed and the square root of x squared plus 6, basically the same thing. And I wrote u is equal to x squared plus 6 and did a u sub that somehow worked. I am not sure exactly what I did, but if I were to try that again, say u is equal to x squared plus 1, we would be left with Still not sure how that works. Actually, oh, I think I understand now. I understand how I did it now. du is equal to 2x dx. Therefore, dx is equal to 1 over 2x du. And when we substitute dx, we get 1 over 2 is the integral of x squared, which would be u minus 1 times the integral of u. Ah! Sneaky. The u sub, not integration by parts. Du. And we can kind of simplify this out even further. Just factor everything out. We get u to the power of 3 over 2 minus u to the power of 1/2 du. And if we take the integral, we get 1/2 times 2 over 5 u to the power of 5 over 2 minus 2 over 3 u to the power of 3 over 2 du. Substitute, ooh, the lag. Substitute the x's back. We get 1 over 2. Alright, let's simplify while we're at it. 2 and 2 cancels out. So we get 1 over 5 x squared plus 1 times 5 over 2 minus 1 over 3 x squared plus 1 times to the power of 3 over 2 plus c. Oh, right. Oh, I did remember to put plus c. I keep thinking that I forgot to put plus c. And this is right. So keeping notes help. I don't think I could have figured out this problem without my notes from last time I did this. And ooh, that's a spider. This is a big nope. I do something wrong somewhere. Doesn't look like it. I don't know. How? I don't think my answer is wrong. I need to find the full problem again. Do I? 1/2. Okay, time to grab out the textbook. Let's see, which page is it? The textbook says a answer that's really different, but I don't think I did anything wrong here. Number 45. Looks about right. Scroll back down and... Ooh, the graph is even here. That doesn't look right at all. I have the same answer as my calculator, which has a different answer from the textbook. When given the exact same question, do I trust my calculator or do I trust the textbook? Wait. About du? And gone. Do I need to multiply by 2x? I think that is the problem. Because du is 2x. So actually when we integrate, we wouldn't have... Wait, no. Wouldn't have du anymore. So... How? The textbook gives the answer of 1/3x squared times 1 plus x squared to the power of 3/2 minus 2/15 1 plus x squared to the power of 5/2 plus c. Now that looks completely different. How does it get an extra x squared over here? Unless these two are the same answer, but one's for integration by parts. Highly confused. Well, I'm gonna trust myself for this one. Because I know there was one other time where the textbook had a problem. It was as x approaches 0, y approaches 1/5 minus 1/3. So negative 2/15. Let's say that's 0, negative 2/15. As x approach infinity. Actually, this is a really weird function. But because it's squared, this is bigger. It would be pointing up both ends. I don't know if it would be wider or thinner than the original. There's fractions, so I assume it would be wider. Kind of like that. I don't know. Actually, that does look pretty similar. I need answers. Oh my god. Okay. I will leave the answer as this for now. Because I believe in my answer. But once stream's over, I'm gonna go back and double check everything for like an hour. Which, if we were to say that's the answer, we reach our final question, which is to prove that the integral of natural log of x to the nth power is equal to x times natural log of x to the nth power minus n times the integral of natural log of x and minus 1. Okay, so this is actually a reduction formula. Something I was trying to remember earlier. Where we have a really high power, but we can gradually reduce it one by one. Or just do all of them at the same time. But this shouldn't be too hard. Or u must be equal to natural log of x to the power of n, or dv must be equal to 1. That means v is equal to x, while du is equal to n minus 1. No, n times natural log of x to the power of n minus 1 times 1/x. If that's the case, we say let's write down our formula here, which is that udv is equal to uv minus vdu, to show that we're using integration by parts. So we get uv, which is x natural log of x to the power of n, minus integral of n. N's a constant, so n can go outside of x, and 1 over x cancels out, so we're left with natural log of x to the power of n minus 1 plus c. I think we can leave this entire thing as our answer. Do we need to plus c here? There needs to be dx here, I know. Well, the question didn't have dc c, but any integral would have c. But we still have another integral here that's unsolved, so I guess not. This entire thing shall be our proof that the reduction formula works. From my squiggly box. I still want answers. What if why, how does a textbook get its answer? How's that work? Oh well, we'll leave that for next time. Or rather, I won't be proving that at all. Today we have completed, ooh. Look at how long the integration by parts section is. We completed some questions for 6.4, which was all about work. If you take physics, this is pretty much gonna be what you're gonna be doing the entire time. All kinds of work related stuff, even spinning things, centrifugal force, all that. Average value definitely the easiest out of those 3 sections for today. We just take an integral and we divide by a number and that's it. And then there's this thing, which isn't that hard, but takes a long time. Oh, that will be it. Where's the math for today? It's time to move on to what I want to do, the Minecraft changelog. Or rather, hang on. I need to launch the server. Right, background music, you can stop now. We're going on to fun stuff. Fun stuff for today, if you made it here, if you're still alive and awake. We're about to show the fun stuff. I don't think anyone's still alive at this point. And let's see. Gotta launch the server. There's too many things running simultaneously on the computer. Come on. Log in. Still black screen now. Just hang on, don't want anybody to see my password. Oh, server is up. So is Minecraft. Ow. Alright, on to the alpha server we go. Now this is one of my favorite things. Or rather, is this an outdated version of the item? The Templar Spear. Oops, not the Banner Spear. That's still in progress. The Templar Spear. This is a melee weapon, does 20 slash damage, but it has some really unique effects. Like, look. Let's clear the weather. Oh, I'm surprised, look. It's a thrust, and a slash, and a sweep. I spent so long on the mass part of this weapon, especially making the sweep go at certain angles. The first attack is a thrust attack, second one's a slash, and the third one's a sweep from left to right. And if you look up, it will sweep upward. If you look down, it will sweep downwards. Down to a certain angle, where there's a limit to how high the slash can be. So you can't really hit anything above your head. So you gotta try to keep at the same elevation as the target. But if you right click, these are the left click combos. If you right click, it will do an upward slash that will knock enemies up. And if you click again, within 2 seconds of your first attack, you can do a slash that does a lot of knockback and also does heat damage. If you see the flame particles, it's doing heat damage in addition to slash. I do plan on adding a lot of different combos like left click, right click, left click. Almost like Windcraft. It can also differentiate between attack while mid-air and attack while on ground. But I don't have any air-based combos right now. I only got 2 basic ones. These were just to test things out, but they work. If we go GMA, oh no. Loadout. Well, I don't have a loadout. Let's get Envoy and Nucleus. Alright. I have 200 health now. I'm gonna spawn the test mob, which is a Templar. And we go to survival mode, it's chasing us, and it does the same attack as this weapon. It's a duel. It's a duel with spears. I don't want to get range. I don't want to get range of that because that attack can be pretty dangerous, especially due to how much heat proc it builds up. Oh god, this game is running on mute right now. Give me a second. Let's turn the sound up. Oops. Let's recharge because I also have abilities. I can do things like do double jump. Oh, he just friendly fired and killed that Twisted. Well, not friendly fire. The Templars are not friendly with the Twisted or the Marauders. They're all enemies with each other. So if they can't find a player to kill, they'll start killing each other. Now, if I get hit by one of the combos, you can see the last attack does all the knockback. And it builds up a lot of heat. Oh. And it got sniped by a shotgun marauder. That's that. Spawn another Templar. Hey, Abby VT. My title? If you my rank, that's recruit, or if you want to know what to call me, I'm Anon. And You see, this is the combos that I created. You can hit them up and then, oops, that missed. Oh, don't get hit by that. Stream, I mean. The calculus torture, but calculus was just over. We just finished up a minute ago. So I'm doing a little bit of changelog before I just end the stream. The title's really long. It's the entire title of a math textbook. But if I get hit, yeet, and that hurts a lot. Calculus will always be with you. And that's basically how this weapon works. It's still in progress. I'm still trying to give it some mods, but I haven't gotten to it yet. I was very busy. Happening here on Minecraft, we're on the velocity test server. ZIP. Oops. The IP for the actual server is velocity.passwords.net. I'm just doing a little showcase, a little devlog of what I've been working on. And if we spawn another mob, I don't know how low the health for the Templar is, but these guys will fight each other. And he's getting multiple headshots. Oh, he just missed his combo. Envoy goes in with a shotgun, and the Marauder's dead. Oh, not the Marauder. I don't want Marauder. Templar. Let's see them go again. Ooh, got Shadow and Bleed here. We got Bernie on this side. Always almost dead. Marauder still has 300 health left. Okay, let's finish him. This mob doesn't drop anything yet. Still in progress. When it's actually released, it's not gonna have 1,000 health. The 1,000 health was just for me to test things. Melee weapons, these have pretty long reach, an entire 7 block range instead of Minecraft's 4 or something, 4 or 5. But because everyone else has guns, you still have to be really good at getting close to the target. Anyways, that's what I've been working on. Weapons still work in progress. This will probably be released next weekend. Yeah, next weekend would be a safe bet. I wanted to add bosses this week, but sorry. I could add a mini boss. I do plan to add a mini boss that which drops a new explosive weapons. Oh, speaking of which, I haven't showed them off yet. We got the mill core, and we got the RPG 7. Ooh, and a cool little hat. I'm gonna take that. It's blocking my field of vision. And we suppose that these use rockets. I know the milker shoots grenades, not rockets, but this is more for fun and balancing instead of for realism. Especially the RPG. Now these can take pretty long to reload. RPG takes currently 4 seconds. Don't know if I want to change some. The milker holds 6 rounds. Shoots a grenade. And ooh, milker currently doesn't show you the blast radius, but the radius is going to be 4 blocks. 4 block radius. You can shoot 6 bullets up at a time. If we spawn in the Templar, I can shoot them. These rocket launchers have a very high knockback. And now you can see the milker is affected by gravity, and also there is friendly fire. You can in fact rocket jump if you have the health for it. But the RPG is a much more devastating AoE weapon that has a huge 6 block radius blast. And currently 130 damage, almost twice as much as the milker. Let's see if we can snipe that Marauder over there. shoot the ground below him, and he can blast it off into the air. Another part that's different with the RPG is it's only got one ammo. However, it's not affected by gravity. Again, not for realism. With most of the other guns, I've tried to achieve realism, like the velocity, the damage, the penetration power. I've tried to stick with realism before with all the other guns, but now I'm just trying to make things more interesting. Because again, in a realistic environment, you would not be wearing some crazy exoskeleton. Ooh, he got up real high. The blast, knockback, etc. for the grenades, rocket launchers, all configurable, so it'll be really easy for me to reproduce one of these. Rocket jump. Ooh, that's high. Am I gonna die from this? No. Oh, and another marauder, one shot. Alright, well, that will conclude this devlog section. We got a new melee weapon and explosive weapon, and probably a mini boss coming up. I'm thinking of making a Templar variant of the mini boss as well, because shield, don't have shield, right shield. I'm thinking of making a mini boss with a Templar first, one that holds a regular spear and a shield, but the big bosses are definitely not gonna be coming this update. I'm sorry, I know I said it would, but I don't have time. I got caught up making this thing. But yeah, anybody still watching, thanks for staying with me, especially if you lived through the torture. But I will be seeing you on Monday for a Lobotomy Corporation stream if you're interested. But for now, I'm gonna skip the bye screen and goodbye.